Okay, today we're going to talk about when you have negative integer exponents. When you have negative integer exponents, you have to be careful of what you do with them and where they end up. If you look at our negative exponent theorem, it says specifically, if you have some base to some negative exponent, all you have to do is you take that base and you put 1 over the base to the positive exponent. So it's essentially it's reciprocal. So it started off in the numerator and ended up in the denominator, and vice versa. So just remember, instead of trying to remember the 1 over business, just remember that a negative exponent means a misplaced base, meaning that the base is in the wrong spot. To fix it, you just move it from the numerator to the denominator, or vice versa. So let's see how that actually works here in the next example. Okay, example 1, write the following as a simple fraction. So here we have 5 to the negative third power. We see that negative 3 popping up here. So all that means to do is, since this is technically 5 over 1, all we do is we flip it around. So this becomes 1 over 5, and then when you flip it to the opposite, it went from the numerator to the denominator, you make this negative 3 a positive 3. So then it's just 5 to the third power. So then you would actually evaluate this because they want it as a simple fraction. So this is not simple enough. We know what 5 to the third is. Well, 5 squared is 25, and then 25 times another 5 would be 125 as 5 cubed. So 125. So there you have it. There's your simple fraction. We know 1 over 125, those don't reduce, so we leave it as such. So there's our simple fraction for that one. Alright, for part B in this example, we want again write as a simple fraction. We've seen something like this before in the last lesson where we had scientific notation. You have 5 times 10 to the third power over 1.2 times 10 to the 8th power. So again, we can keep these together and operate with those alone, and then we can also do the 10 to the powers over here by themselves as well. So let's figure out what 5 divided by 1.2 is. So let's use our calculator for that. So 5 divided by 1.2, and that gives us 4.16 repeating. So let's see if, since they want it as a simple fraction, let's see if that is easily math-frackable. So let's go ahead and do that. So I'm going to answer frac, and oh good, it is. It's 25 over 6, so let's go ahead and write that as 25 sixths. So 25 over 6. I left a little bit here because I know this 10's got to go somewhere. I don't know if it's going to go upstairs, downstairs, or what. So let's evaluate this here. So 10 to the third over 10 to the 8th. Well, we're dividing, so we subtract our exponents. So we get 10 to the negative 5th, which typically would end up on top. But since it's 10 to the negative 5th, it's going to go down here. Negatives go on the bottom, remember? So 10 to the negative 5th. But when I put it downstairs, it becomes to the positive 5th power. So we leave it as that. So now, this is not a simple fraction. A simple fraction just has simply an integer in the numerator and the denominator. So we need to actually figure out what this is. So 10 to the 5th power. Well, let's see how many zeros that has. So 10 to the 5th power has, well, 1, 2, 3, 4, 5 zeros. Imagine that. So 5 zeros. Then we got to multiply that by 6. So that's really just going to become 600,000. So 600,000 on the bottom. Let's scooch that out of the way. So we still have 25 on the top and 60,000 on the bottom. Excuse me, I keep saying that. 600,000. Let's put a comma so I don't make that mistake again. 600,000 on the bottom. Let's see if that reduces, because likely it's going to. That's divisible by 5. That's divisible by 5. So let's see what happens there. So we do 25 divided by second answer, and ooh, that's not what I want. Second answer. There we go. Enter. Okay, we get something nasty. Let's see if it'll go back into a fraction. And it doesn't. So we're going to have to do this by hand. So, like I said, I know they're both divisible by 5, so let's just do that. So 25 divided by 5 is 5. Okay, that was easy enough. Do 600,000 divided by 5. Let's see if that works. 600,000. Let's see. 1, 2, 3, 4, 5 zeros. That's what we wanted. Divided by 5. Alright, and well, there we go, 120,000. So let's write that down here. Oops, 120,000. Now, you might recognize that, guess what? These are both still divisible by 5, so let's keep going. If you can keep going, please do keep going. So, we know 5 divided by 5 is easy. That's 1. And then we have 120,000. We got to divide that by 5 one more time. And there we go. We have 24,000. So 1 over 24,000. Whoopsies. Sorry about that. It's a little messy, but you get the idea. 1 over 24,000 is our simple fraction for this guy. Which might not seem as simple as you'd like it, but if you notice, much simpler than this guy, so it'll work for us. Alrighty, let's go ahead and take a look at what else we've got here. Okay, example 2 says we're going to rewrite Newton's law of universal gravitation, which is the following: W equals g of mass 1 times mass 2 over r squared, but we're going to use negative exponents. Right, so we basically want to get everything out from underneath, which it's going to be easy enough because guess what? This is the only thing we have downstairs. So it says to use negative exponents, which is really odd. Typically we don't want to use negative exponents, but here they want us to. So all of this stuff is on top, so I'm going to leave it where it's at. We're just going to say g of mass 1, so m sub 1, and then mass 2, which is m sub 2. And then now if we wanted to pop this guy upstairs, if we are moving its place, we have to then make it the opposite sign of what it was. So we have r not to the positive 2 anymore. This would be r to the negative 2 power. And now everything's upstairs. That's what they wanted by negative exponents. They wanted everything to just be on one line, no fractions involved, but having a negative exponent, which I guess they like better. Example 3, rewrite each expression as a single power using only positive exponents. Okay, so even though we have 10 to the 3rd and 10 to the 7th, we're going to keep it as a power. We don't want to actually evaluate it, but we do want positive exponents. So here's what happens. So we have 10 to the 3rd over 10 to the 7th power. So 3 minus 7 is 4 again. In this case, it's negative 4. Typically we'd put these on top, so 10 to the negative 4 would pop it down into the bottom. So we have 10 to the 4th downstairs. So we have 10 to the 4th. We got to have positive exponents. That's why we couldn't keep it upstairs. But that begs the question, what do we put upstairs? If I don't have anything there, the only legal thing I can put into a fraction is going to be 1. So you have 1 over 10 to the 4th power. Okay, that's it. That's all we can do with that guy. Here we have t to the 5th times t to the negative 1st. Now remember, we're multiplying our bases here, so that means we're going to add our exponents, which means we're going to take t to the 5, and this is going to look a little weird for a second, but this is how it's supposed to happen, 5 plus a negative 1, because we're adding our exponents here. Now 5 plus a negative 1 is the same as 5 minus 1, as we know of our properties of addition and subtraction here. So 5 minus 1 is just t to the 4th power. Okay, it's actually subtracting because of that negative, but that's the only reason. The property still says to add, but since we have that negative, that's why we subtracted. So it becomes t to the 4th power. Alright, still example 3, so same directions. Rewrite each expression as a single power using only positive exponents. So same thing here, we just got a little bit more complicated of a situation. And like I suggested to you before, I would recommend taking this one single baby step at a time until you get good at these. Then when you get good at these, you can start taking them more at a time. But for now, let's just do it one step at a time. Now remember, if we have 7 times k in here, you can treat these as 2 separate little entities here, separated by a multiplication sign. So both of these things need to be taken to the negative 3rd power. So we have 7 to the negative 3rd power, and then k to the negative 3rd power. Whoops, forgot my negative there. There we go. So negative 3rd power. And then this stuff is just being multiplied by this stuff over here. Okay, again, 2 and k are separate things. Now k squared, that's all one term, so that stays together. So we say times, now the 2 to the 5th, this 2 needs to get hit by the 5, so 2 to the 5th power. Oops. I'm sorry. Let me go ahead and erase that. Erase. Get rid of that. Alright, sorry about that. 2 to the 5th, not 5. So 2 to the 5th power. And then k, now this is going to get a little tricky here. So k squared to the 5th, remember, that's our power to a power rule, which means we then multiply those exponents. So k, 2 to the 5th, so 2 times 5 is going to give us k to the 10th power. I know that's weird because we didn't do that over here, but k didn't have an exponent. So essentially it was just 1 times negative 3, which is just negative 3. That's why we had to change it here to 10. Alrighty, now we got a bunch of stuff to clean up here. Let's address these negative powers first because we want positive exponents, so let's get those where they need to go. We know negative exponents just means a misplaced base, meaning it's got to go downstairs, which means that this stuff is going to be our upstairs stuff because those both have positive exponents. So we'll leave that upstairs, so 2 to the 5th, and then k to the 10th. I guess we could have figured out what 2 to the 5th is, but we'll do that in a different step. Why not do too much at the same time? These both things are going downstairs, so let's move these downstairs. So we then have 7 to the positive third now, which we can actually evaluate. And then k to the positive third as well, so k to the third downstairs. Alright, now let's start evaluating and seeing what we can come up with here. So 2 to the 5th, let's figure out what that is. So 2 to the 5th, let's get this calculator all the way on the screen here. 2 to the 5th power. Third 2. Alright, 32. So 32k to the 10th. Over, 7 to the 3rd. I think that's 343, but let's double check here. That is 343, so we're done with that guy. So 343. 3. And then still k to the 3rd down here. And we can still keep going here. K to the 3rd. Let's address our k's. Well, no, let's keep working with our numbers because that's where we started out. Let's see if 32 over 343 reduces. I don't believe that it does, but it doesn't hurt to double check. So 32 divided by 343. Get that as a decimal and then math bracket. If we end up with the same thing, yeah, it doesn't reduce. So that guy is as reduced as it gets. So we'll keep this as 32 over 343. 43. And then let's address our k's. So we have k to the 10th over k cubed. So when we're dividing here, we do 10 minus 3, and that's a positive, so that ends up upstairs. So k to the, well, 10 minus 3 is going to give us 7. It's a positive 7, so it ends up upstairs. So 32k to the 7th over 343. I know it doesn't look very simple, but that's as simple as we can get it because we only have 1k, and we have just a number that doesn't reduce as a fraction here, 32 over 343. Alright, example 4 says use the number 1,000th for the following. So before we even go any further, let's figure out what 1,000th is. Now you might be thinking, ooh, 1,000, I know what that is, but be careful, this th here represents that it's going to be the decimal place 1,000th. So we are starting with the decimal. Now remembering decimals, we have first comes the tenths, then the hundredths, and then the thousandth. So if I have one of those, it's going to be 1 here. So 1,000th for the following. Okay, so that's the number we're using. We need to write the number given using negative exponents, which means it's going to be some multiple of 10, because that's how we get 1 here. You can't use 1, that won't work for us. So we got to get this guy to 10 here. So we got to figure out, alright, well if I made this 10, if 10 was here, my decimal would be right here. Now how would I get from this decimal back to the one I started with? So it would be 1 spot, 2 spots, 3 spots, 4 spots to get to the back to where I started with, and we went 4 spots in the left direction to get from 10 to 1,000th. So we'd say 10, 4 spots in the left, if you remember scientific notation, gives you a negative 4 here. So 10 to the negative 4th power gives you 1/1000th. Okay. Alright, so now we need to write the number as a decimal. Well, you know what? That's actually what we started with here. So we had 0.001 as our decimal, and that's, I mean, we just came up with that number, and there's your decimal point, and it's as a decimal, so you're good to go. Last thing, we need to write the number as a simple fraction. Now I'm going to go back to part A, where we had 10 to the negative 4th power here, because it's going to be easiest here. Now we're allowed to use fractions, so what I'm going to do is make this a positive exponent by putting it downstairs. So we end up with 1 over 10 to the 4th power. Now to be a simple fraction, you're not allowed to have any powers in you, so you actually have to figure out what 10 to the 4th power is. So let's go figure out what 10 to the 4th power is. So 10 to the 4th power gives us, oh, well, 10 with 4 zeros, or 1 with 4 zeros, which makes sense. So that would be 10,000. So 1 over 10,000. And there you are. There's your simple fraction. We want this piece right here. That's all.